Hi there. Welcome to Coding Across the Curriculum, where I'm going to show you how to use coding in other areas of the curriculum. Today, we're going to be using Scratch to compute simple calculations. You could do this to help you learn basic facts or answer questions you can't figure out in your head. You can use this in the sciences to find answers to difficult formulas very quickly. You could even use this to convert units or to scale up recipes, with some tweaking of the basic ideas of this video. We'll be using 3 sets of special blocks to do this activity today. The ask and wait, answer, and variable blocks, the green operator blocks, including the join block, and the if-then block. Before we begin though, let's take some time to think about who will use the programs we make and how will they use them. Do we want to be able to do one calculation at a time, or many? How long will the answer stay on the screen? How many questions can be asked at a time? I put my ideas roughly down on this paper. I'm going to start really simple. I just want a program that will add any 2 numbers for me, numbers that the user can put in. To do that, we'll need to first tell the user what the program does, ask a few questions to get some input, calculate the result, and finally, share that result with the user. Now that we know what we want to do, it's time to talk about the tools we're going to use to code this. If you want to skip to a different part of the video, because maybe some of it's too easy, click on the timestamps below in the description. If we want to interact with our user, we will need to ask them some questions, namely, which numbers do they want to add? Then, we will need to use that answer to figure out the addition problem. Scratch is kind of like Homer Simpson. When it learns a new thing, it forgets the old thing. It can only keep one idea in its head, or, in this case, the answer block, because that is all the space that there is. So we need to use some variables to store that information for later. Using a variable is like keeping a bunch of envelopes of different information. So I have my green envelope, my orange envelope, and my red envelope. If I ask a question and get an answer, say, what number do you want to add first, and I get the answer 7, well, I can write that 7 down on a piece of paper, so that it goes from the answer block to my variable into the folder. Later on, if I forget and I ask another question, I can always look in this folder and remember what that number was. So now I ask another question, what's the second number I'd like to add? Say it's 6. Well, I can write that number 6 down, and I can put that into a different envelope. Let's say the orange envelope. So now if I want to remember that first one in the red one, I can pull out the red one, look, and it says 7. The ask and wait and answer blocks are in the blue sensing blocks because they give us some input from the user. We've got our ask and wait, and we've got our answer block. The variable blocks are in the orange data blocks. When you first click on them, there's nothing there. So what we need to do is we need to make a variable. For the purposes of our program today, we're going to make a variable called number1. We're going to make another variable called number 2, and we're going to make a third variable called results. The green operator blocks are blocks that many people don't know much about, but they are very important to any good Scratch program. Today, we're going to use the mathematical operations blocks, plus, minus, multiply, and divide. They do exactly what you'd think with the 2 numbers we give them. We're also going to use the join block, which can help us make our sprite say our answers in a sentence. Because if our sprite just says a number, we don't really know what that number means. The green operator blocks are found here. The 4 operations we're going to use today, addition, subtraction, multiplication, and division, are all found at the top. The join block is down here. We usually use this with a say block, and we can have the character say the 2 words or 2 things that are in there. So if I click on this, it says hello world. But if we wanted it to say hello world, we just type hello world. The great thing about this is we can actually add the variables. So in this case, I'm going to put number 1 in there, which, since we haven't done anything to it, it should be 0. And when I click on that, it should say hello 0. The if-then block is quite handy as it helps our program make a decision. It checks to see if something is true, then it runs what's inside if it is true. So for example, I might check, is it going to rain outside? If it is, then what I need to do is run my program, get my jacket. If it's not, I'll ignore those steps. But since it is clearly cloudy outside, I got my jacket. It only asks this question once though. So if I run that program in the morning and the weather changes later in the day, I'm not going to be prepared. But luckily for me, my brain works a little differently than Scratch does. This is different than the if-then-else block, which will do something else instead. So for example, I might say, oh, it's not raining right now, so I need to put my sunglasses on. The if-then block can be found in the yellow control blocks. Notice that there are a lot of similar blocks here. For our program today, we're just going to use the if-then block with the one opening in the middle. Now we're ready to put our blocks together to make a very simple calculator. Let's switch the backdrop first. It's important that we pick a backdrop that has something to do with what our program is about so that it doesn't distract from the function, that is, what our program is meant to do. I'm going to pick a school here. I'm also going to change the sprite because it's nice to have different people on there. So I'm going to pick Danny here. And Danny's a bit big, so I'm going to use this tool up here after Danny loads to make Danny a bit smaller. That's a bit better. And let's get rid of the cat. So now that we've got Danny, and Danny can start there, every program needs to start with an event block. So let's choose when the green flag is clicked. And we need to let our user know what this program is going to do for them. So let's choose a say block and tell them this program will help you add 2 numbers. So now that we've told them what it's going to do, we will need to actually ask a question. So let's ask, what is the first number you would like to add? So we're going to go back to our variables and we're going to set number 1 to the answer that we've got, because like we said before, if we don't set the answer to something else, it will be forgotten when we ask this next question, which is, what is the second number you would like to add? And then again, we're going to set our variable number 2 to the answer. So now that we've got our 2 numbers, the next step of our program is going to be to do the calculation. And that's a fairly straightforward procedure. So we're going to set result 2, and then we're going to use our green operator block and put it in there. So our result is going to be number 1 plus number 2. Pretty straightforward. The last step of our program is that we need to share this result with the user. So let's put a say block, and we're going to use a good number of these join blocks. So the first thing we're going to do is we're going to say that number 1 plus, pull that number 2 out, plus number 2 is, and let's join those 2 together. So number 1 plus number 2 is, and we're going to join that whole number thing with result. And we'll put that into the say block. And that's how you make a simple addition program. Now it's your turn. See if you can make a program that can compute a simple calculation. Pause the video while you work. It's really important when we are coding that we learn how to check and debug our programs as often as we can. We want to catch our mistakes early and fix them before we have too many lines of code to sift through. I want to make sure that my program works exactly how I figured it out in my head. In this program, there are a few things that could go wrong, so let's give it a go and see what happens.
I'm going to have to give some numbers here. So I know what 2 plus 3 is. So I'm going to use that to test it. So 2. And the second number I would like to add is 3. 3 plus 0 is 3. Which actually isn't wrong, but it is not the answer that I was looking for, or it's not the result that I was looking for. So I need to go through each line of code to see what is wrong. Now, as I scan down here, I notice that I put the wrong variable in the second bit, so I need to change that to the correct variable. Did you also notice that the words were all smushed together when Danny gave us the final statement to give us our output? And the interesting thing is that when you are using the join block, it does not add spaces in. So we need to add those spaces in at the beginning and end of plus, and at the beginning and end of is. And it would also be nice for us to see that answer, that result a little bit longer so that we would have time to read it. So I'm going to change this from 2 seconds to 4 seconds. It's important to constantly check your program to see if it does the right thing. Otherwise, you're going to need to change the code. If you don't check it periodically and regularly, then you could find yourself with loads of problems at the end of the coding and you wouldn't know where to find them. So it's good that we checked this and found these 2 problems now.
In future videos, we'll have a look at debugging, which is where we find and fix our mistakes. Stop the video now and try your program. Does it do what you want it to do? This program is pretty boring and simple. It only allows us to do one thing: add 2 numbers. We're going to add an option to do the other 3 operations: subtraction, multiplication, and division. I've made another plan for this new part of the program. So we begin with explaining the program, asking which operations we want to do, and then our program will branch into 4 different things. We'll have a branch that will do the addition, a branch that will do the subtraction, a branch that will do the multiplication, and a branch that will do the division. It's really helpful to draw out what you want your program to do so that when you code it, you have a better idea with what you're doing.
To give our user a choice, we will need to ask a question and wait for the answer. At the beginning of this program, let's change what the program asks or explains at the beginning. This program will help you add, subtract, multiply, or divide 2 numbers. And let's just tidy that up a little bit so it looks proper. And then let's put another question in there and say, what would you like to do? Add, let's put an A, subtract S, multiply M, or divide B, and a question mark. Now we're going to use an if block, and in this case, since we've already got the addition section sorted out, we'll keep that. So underneath, we're going to put an if block and put all of this inside that if block, because like we said, if our answer meets a certain criteria, which is if it's A, we want it to complete all of this code. Otherwise, if it's not A, we can skip that. So to do that, we just pick an operator block that equals 1, and if our answer equals A, then, whoops, I've made a mistake there. Let's put that number back in there. So now it's going to tell the user what to do, ask if it wants to add, subtract, multiply, or divide. If the answer is A, then it's going to go and ask the first number, the second number, put them in the variables, figure out the result, and then say the result. Now, to do our second one, we're going to duplicate this, and we're going to need to make some changes. So we're not trying to find out if the answer is A, we're looking at if it is S. And then instead of saying the first number we'd like to subtract, what is the number you would like to start with? And then what is the number you would like to subtract? Now we need to make sure that we change this operator from a plus to a subtract. So I'll just swap those variables in and out. As well as we need to do, instead of plus, it should be minus, and just double check that I've got my spaces in there. Now all we need to do is complete the other two options. It's pretty much the same process, so I won't bore you with the whole thing.
While I'm finishing off my program, why don't you try adding some more choice to yours? Don't forget to test it and debug it, if necessary, before you return to me. You can take your calculating program to the next level by having it calculate multiple times or calculate more difficult formulas for you and giving you more information. I'll show you how to calculate the circumference and area of a circle for your user using the following two formulae. Circumference is 2 pi r, and area is pi r squared.
To ask the questions more than once, it's simply a matter of adding a repeat block to our code. You can find the repeat blocks in the yellow control blocks right here. You have two options. You can use the repeat forever block, or you could repeat a certain amount of times. So if we wanted this program to go on forever, we could start it there, and now the whole chunk, all four operations that I've filled in, are repeated there. You could also have maybe inside of each block, maybe have it do two questions. You could play around with this and ask more questions and ask how many times it wants to repeat, the user wants to repeat. But I'm going to take these out now and just leave the program as a simple one for you to check on your own time. I've set up a new program to do some different calculations. This is actually a bit simpler than the original program in that we've only got to ask for one thing, which is the radius of a circle. Let's get our event block and explain what this program will do. So this program will calculate the circumference and area of a circle. And we need it to ask what is the radius of the circle. For this one, we're going to make a variable called circumference and another variable called area, and let's just take those off. So we're going to set let's set circumference to it is 2 pi r. So let's do our multiplications. We're going to use 2, and we're going to use pi as 3.14. And let's do another multiply. We'll multiply that whole thing by the answer. So we set the circumference to that. Then let's take the area, and that is pi r squared. So let's do 3.14 for pi, and then our r squared will be our answer times our answer, and let's pop that in there. And the last thing we're going to need to do is tell our user what our results are. So and we're going to pull those out and take a couple join blocks. So the circumference is circumference, and let's put that in there, and the area is area, and let's put that in there. Now let's try that. So this program will calculate the circumference and area of a circle. We need to probably add a little bit more time. Let's put 4 seconds. What is the radius of the circle? Let's say 5, and the circumference is, and the area is that.
Now it's your turn to add some things to your calculation program, or to make a program that can calculate something else, if you'd like. What different formulas or calculations can you put in your program? Pause the video and have a try. That's all for now. I hope you've learned something from this. Please check the description for links to some sample programs. You can also click on the timestamps to review any parts of the video you didn't quite get the first time. If you've used the video to make any programs that calculate some interesting formulas, please post a link in the comments. We'd love to see what you've made and would help anyone else watching the video. If you liked what you saw, please click subscribe and watch our other videos, which will be coming soon.